We're Group 9. Our topic was harvesting thermal energy. So we threw around a bunch of ideas and a bunch of applications. One application was PC cooling. PC fans at 6 watts apiece. There's roughly 1 billion computers in the planet right now, and we figured we could save a lot of energy by replacing all of those PC fans with something that harvested that thermal energy and converted it into mechanical cooling energy. We came up with the idea for electric cars of building a Stirling engine. This is our first concept. The idea is that an electric vehicle produces a lot of thermal energy through the battery array and the engine controlling unit. We want to harness that energy, convert it into mechanical to power the cooling fans. Otherwise, the cooling fans are powered by electricity, which is just wasted power and wasted efficiency when it comes to the mileage you get out of an everyday electric car.
Alright, so I'll quickly go through the manufacturing design. Basically, it's like an internal combustion engine, except we're not applying heat. We're using external thermal energy to create a temperature differential between these two cylinders here. Through this, we're able to generate, just like an internal combustion engine, movement. So through this movement, as Mike mentioned, we were planning on creating electricity. So we basically designed everything from scratch. We researched into a process called the Stirling process. And from there, we came up with all the values, all the design concepts. And then we spent 200 plus hours in the machine shop following our SolidWorks design and machining everything to the engineering specs. And this is our final product that's shown here. We estimated probably around 200 hours of machining time between between two people. And the estimated cost for all material is probably around $170.
Everything in this engine was built within 5/1000ths of an inch. The tolerances on Stirling engines need to be very precise because as the hot air expands in the hot piston, there can't be any slack in the overall design and the dimension between the piston and cylinder wall. Very good. Are we good? The overall idea is to power a fan like this, which is currently used to cool the radiator of an internal combustion engine. We would either power this fan directly off of the flywheel, or convert this mechanical energy into electrical energy and store it back into the battery array, much like a regenerative braking system that already exists in an electric car. All of our flow data that we use to calculate the power output of the Stirling engine to the flow of this fan came from Magna International. They helped us by providing us with this fan, an electric motor, and some template flow data that we use for all of our math. Thank you.
Thanks.